1 equals 1 to the power of 1. 2 equals 2 to the power of 1. 3 equals 3 to the power of 1, and so on. Each number can be raised to the power of 1, and it's still that same number. So here, you could say 2 plus x to the power of 2 plus x is also 2 plus x to the power of 1. But 2 plus x, but 2x to the power of 0 here is the same as 2. It equals 2. It equals 2. Because x to the power of 0 equals 1. Therefore you have 2 by 1, which equals 2. So if we say for variables in x, that means all the numbers. That means all the numbers. Any number can be written as itself and the product of a variable raised to the power of 0. All the numbers, any number, or any, even if I had another variable, I could say a to the power of x, or ax to the power of 0. Ax to the power of 0. That's how you read this term. This term is read as ax to the power of 0, and that is also equal to just a. Because multiplying or raising a number to the power of 0 is equal to 1. This is true because, remember, any number to the power of 0 gives you 1, and multiplying a number by 1 does not change the number. Now I want to show you this because I wanted to show you the basic anatomy of all terms that we're working with, and that way we can really get into the last part of this segment, which I've been working up to. Now we want to talk about terms in the form ax to the power of n. We have ax to the power of n. Here, for this term, let's say we're going to use a capital A. Now we're saying A here now I want you to pay attention. Now A here is, this is a form that's used to describe terms in algebra. Here we're saying A is the number. Or numerical coefficient. it's a numerical coefficient of x. For example, if I had 2x, 2 here would be the numerical coefficient. Two here would be the numerical coefficient. Or if I had any number, 3, if I had 3x, 99x, then 99 would be the numerical coefficient of x. And here, just for x, if I had any term x, 1 is the numerical coefficient because it's 1x. X is equal to 1x. Or if I had just had any variable, let's say if I had the variable y, if I had a y right there, then 1 would be the numerical coefficient for y. Now we have here that a is the numerical coefficient of x. Now if we just had x, that's equal to x to the power of 1. Here, n is equal to 1 for just anything. Remember I showed you, any variable or number can be written as itself taken to the power of 1. Or also you could say, taking a power, or you could also say, raising a variable to the power of 1 does not change the number, or does not change that variable. Raising a number to the power of 1 does not change the number. Or you could say, a number is equal to the same number taken to the power of 1. Here, n is 1. So here we say ax to the power of n. We're describing all terms. And it's centered, notice it's centered all around the variable. So here, x is our variable. Or the object or unit that we're talking about. Here, remember, even though we're using a letter, I'm showing you the form, but here a is understood. That's why I made it capitalized. A is understood to be a number. We're going to discuss all numbers in this form. A is a number. And then I'm going to show you between the terms what is the difference between like terms and unlike terms, and what are like terms. So here n is called the degree. Now remember I said that a here is said to be a number. Therefore, you could also say, let's say if we have 2x, to the power of 2. Here, it's in the same form, but also 2 has a power itself. It's equal to 2 to the power of 1 by x to the power of 2. But 2 to the power of 1 just equals 2. So it's redundant to write it. Therefore, we don't write that. Therefore, we don't discuss that when we're using this form to explain numbers in this form. Now, if we had a different number, if we had 2 to the power of 2 by x squared, that's going to give you 2 times 2 by x squared. And 2 times 2 is 4. So that's going to become 4x squared. But here 4 is take to the power of 1, but it's back in this same form again. And that's why we don't discuss, that's why I didn't write, that's why I did not write another, or that's why I did not write an exponent by a, because it's already understood to be 1. Because we're talking about numbers, numerical coefficients. That's just